Hi, my name is Ailey. For my discussion, I chose the article A Programmable Dual RNA Guided DNA Endonuclease in Adaptive Bacterial Immunity. So, what even is this article we should start with? So, this is the first publication suggesting CRISPR-Cas9 in a way for genome editing. So, what is CRISPR-Cas9? CRISPR is a bacterial defense system which integrates viral nucleases into the host DNA so that later on they can recognize that DNA and destroy it. Cas9 is an endonuclease guided by two RNAs. So what is an endonuclease though? An endonuclease is something that cuts or breaks DNA. The article then goes on to explain when the CRISPR sequence is able to be specialized and tweaked so that it's specific towards anywhere in the DNA that you're looking for and targeting. So I originally chose this article because it is the first publication suggesting CRISPR-Cas9 for genome editing. So essentially, this is a big turning point for medicine. We need to now think about how we will be able to cure or treat people and what this means for health. This also opens a big door towards more research in this and exploring how this works within living organisms, etc. Now, since it's a little bit in the future now, we obviously know that CRISPR has taken a big leap and that this is true, that a lot of these things have been brought up now. Up on the screen now, there's a simplified visual of what CRISPR looks like. So the purple is the CRISPR molecule and the orange is where we want to cut. So it finds the location where it should be and then it cuts that DNA where the target points say to. And then depending on if you use a new custom sequence, you can add DNA there, or it's repaired organically. So overall, what are the key points of this article? It's the first publication suggesting CRISPR for genome editing. Also, another thing that is a key point is what CRISPR and Cas9 actually are within this process. So CRISPR is short patterns of repeats that naturally occur in bacteria as a health defense. And then Cas9 is a protein that is able to make cuts to DNA without any CRISPR system or guide RNA. Cas9 is able to make random cuts. So the CRISPR in the Cas9 is what allows it to be specific. Another key part is that PAM sequences, which are just another short repetition, are required to actually allow the Cas9 to even bind to DNA areas. So without PAM sequences, Cas9 wouldn't be able to bind or cut anywhere on DNA, let alone specific points. And then a few things that I found interesting while looking over this article was that CRISPR cleaves within 5 to 8 base pairs of the where they targeted it to. So it is very accurate within those base pairs that will get cleaved. Another part that I really like about this is the personability of the medicine and how you're able to specialize it and target it towards specific individuals. I also noticed that throughout the article, there was no mention of ethical outcomes or dilemmas. So was this just that the authors didn't expect any to come out of this, or they just didn't address them in this article? I don't know. So going on to discussion questions, I first want you to think about what are some ideas that you have about how CRISPR-Cas9 can be used in the medical field. What kind of diseases do you think it could treat? Do you know anyone you think who could benefit from something like this? And then another question is, should we be able to modify genes that do not cause or affect disease or illness, aka designer genes? Like, should you be able to change your eye color or your hair color? Things like that, or nose size, random things. Should we be able to do them? And then, do you think this is even worth the hype? Is it actually beneficial to be doing this research? What do you think the overall outcome of this will be? Do you think we'll just end up with designer babies and humans?